Let's think through how arrays work. We'll do this using hand execution because it'll allow us to see how the instructions execute within the computer and how they manipulate arrays in memory. Using this, we should be able to see how we can perform an action for each element of an array, using the for loop, for example. So let's get started with this code here. The code starts by declaring an array of 3 elements. So on our memory over here, so on our piece of paper, we can write down that array. So the array's name is data. Now, as a variable, it has a location in memory. The difference here is that this is an array, so it's divided into 3 sections. 3 equal sized sections. My drawing's a little off, but you get the idea. Now, the first instruction, assign to this location the value, in this case 10. So 10 is stored to the location. What is in this location? Well, this is data. That is the whole data array. We want to store it in data at index 0. So look, I could save myself some time here and just put the indexes above the array here, just for my own reference. So data 0 will be this location here. So I'm storing the number 10 in that location. That's that instruction. What's the next instruction? Assign the value 5 to data at index 1. So the value is 5, and I've got to store that in data, in this case not in index 0, but at index 1. So at this location, we would have the number 5. We then have data 2 is assign the value data 0 plus data 1. Alright, so what's data 0? Data is the array here. Data 0 is 10. Remember, you don't have to remember these values. You just look them up in memory, the same as the computer does. So data at index 0 is 10. Data at index 1 is 5. 10 plus 5 is 15. Where do I store that? In data at index 2. So data, index 2, this location here, becomes 15. We can also compute the values of these indexes. So here we can say data at index 0 plus 1, so that would be data at index 1, that's the value 5, plus data at index 2 minus 1, which is data at index 1, which is also 5. So 5 plus 5 is 10. And we store that in data at index 2 times 1 is 2. So the value at data index 2 becomes 10. We cross out this value, and we can write the value 10 inside the box next to it. Now, if we can't fit that next to it, you can write it somewhere nearby if you want. So as we've seen in this, the array allows you to work with individual elements using the index here. The index can be a literal value, such as the number 0 to indicate the first element, but it could also be a calculated value. In this case, we have calculated using literals, but we could use variables to calculate those values. And so that gives us the flexibility to do much more interesting things with arrays. Let's move on and have a look at the next exercise. Let's have a look at how for loops execute before we worry about working with for loops and the arrays. In this code here, we declare a variable I and a variable val. The first instruction then stores the value 0 in this val variable. Excellent. Then we get on to our for loop. Now the for loop has a number of different actions. The first action is to execute this initializer at this location here. In this case, the initializer assigns the value 0 to the variable I. So we can do that. Assign the value 0 to the variable I. The next instruction is a while loop. This is while I is less than 4. So is I less than 4? Well, 0 is less than 4, so that's true. It then runs the body of the code here. Alright, let's do that now. So the body of the code says val is assigned val plus I. Alright, so val is 0, I is 0, val plus I, so 0 plus 0 is 0, and we store that back in here. Now we would indicate that that occurs because this was the value 0, and then we changed it to the value 0. It didn't really change anything, but it did modify, it did have to store that value there, even though it had that value already. Alright, now that we're at the end of the loop, we jump back to this incrementer here. So this is the value that executes at the end of the loop. So in this case, I++ is the same as I is equal to I plus 1. So I was 0, so I is 0 plus 1 is 1. There we go. Then it goes back to the while, back to the expression, the condition of the while loop. So is I less than 4? Yes, it is. We execute the body of the loop. Val is equal to val plus I. I is 1, 0 plus 1 is 1. We store that in val, so val now has the value 1. We're at the end of the loop, so we jump back to the I++, which is the iterator at the end of the for loop. So this becomes the value 2. We do the while expression again. Is I, or while I is less than 4. I is less than 4, so we execute the body of the loop. I know that because I can look up the value. 2 is less than 4. Val is equal to val plus I. Well, val is 1, I is 2, 1 plus 2 is 3, so it's no longer 1, it's now 3. We get to the end of the loop, so back here to this increment, I++, so instead of being 2, this is now 3. 3, back to the condition, 3 is less than 4, so we go back in and run the body of the loop again. Val is assigned val plus I, so what's val? 3. What's I? 3. 3 plus 3, 6. We store that back in the val variable. We go to the end here, I++, so I goes to 4. Is 4 less than 4? No, it's not, so this code ends. So the purpose of the for loop is just to wrap or to neatly package a while loop that has a few extra pieces to it. The while loop initializes, or the for loop initializes the value of I before it executes the real while loop, if that makes sense. It then has a while loop, which is executing while I is less than 4 in this case, whatever the condition is here. And at the end of that loop, so once it's done all of these instructions, it does this at the end of the loop before it comes back and checks the condition. So it's just a way of wrapping together neatly an initializer that initializes the value at the start, the expression which checks the value of this variable, and something to update that variable at the end of the loop. So let's put that together now for hand executing an array inside a function. So in this case, I've been passed a number of values in an array. So let's take those values as given. So here are the array, or here are the values that we're given in this vector at the start. Remember, the vector has a dynamic size, so we know that the size in this case is 4. So we could just write that over here. And we've got our indexes 0, 1, 2, and 3 to access the individual values with a size of 4. So what happens now? Well, the first instruction in this function is to initialize a variable called result. So here's our result, and we're going to initialize that to the value 0 when we create it. Alright, what's the next instruction? This is our for loop. Inside this, we're actually creating the variable I inside the for loop itself. We can do this. So we have I, which really stands for the index of the array or vector element that we're working with. It's an integer, and it's initialized to the value 0. So that's this initializer here running. We then do our check. Is I less than the size of the values? Well, we know that the size is 4. So I is 0, 0 is less than 4. Let's run the body of the loop. Result is equal to result plus values at index I. Well, let's start with result. Result is 0. We need to add to that results at the expression I. So what's the value of I? I is 0. What's values at index 0? Values at index 0 is 7. So 0 plus 7 is 7. So we store that in result. So result now has the value 7. We now go to the increment here, I++, and so this is now no longer 0, it is 1. Check the condition again. Is 1, I, less than 4? 1 is less than 4, so let's run the body of the loop. Result is equal to result plus values I. Well, result is 7. What's I? I is 1. What's values I? Well, values I, or values 1, because remember I has been calculated. We've calculated I is the value 1, so its values at position 1 is -1. So 7 plus -1 is 6, and we store that inside our result variable. So we access this element in that case. Get to the end of the loop, we increment the value of I. So instead of being 1, it's now 2. We check the condition again. Is 2 less than value size? 2 is less than 4. So let's run this body again. Result is equal to result plus values at index I. What's index I? Well, I is the value 2. Values at index 2 is 5. Result is 6. So 6 plus 5 is 11, and we store the result inside value. We store the value inside result. That's what I'm trying to say. At the end of the loop, we add 1 to I. So this becomes 3. 3 is still less than 4. So therefore we run the body again. Result is equal to result plus values at index I. So let's have a look. Result is 11. Values at index I. Well, I is 3. Values at position 3 is 9. 11 plus 9 is 20. So the answer in result is now 20. And we get to the end of the loop. So we go back, do I++. So this is no longer 3. This is now 4. Is 4 less than 4? No, it's not. So this means that we end this for loop and we return the result. So in this case, the result of this function will be the value 20, which we've calculated here. The important thing to notice here is how the variable I iterates over each of the indexes in the array. Notice that the body of the loop was executed for each element. When I was 0, we were talking about this element here. When I was 1, we were then talking about this element here. When I was 2, here we go, we were talking about that element there. When I was 3, we were talking about that element. And when it got to 4, we ended because that was the end of the array. We'd finished all of these elements in the array. It wouldn't matter how many you had, it would perform the same result. I'll quickly run over this one more time without the illustration or without talking through it, just to give you an idea of how to do that with the different values. You can check out or watch the use of that index as we go. So the result of this sum call is the value 6, which we can see is correct. It is the sum of those values. Notice how the index I tracks the position in the array that we're currently working with. Have a go at this with the different functions in task 6.2.